Hello and welcome back to TipIce. In today's video, we are going to talk about the data that we collected in the previous video and show how Beer's law is used with spectrometers to calculate the concentration of an unknown substance. So I use the Jupyter notebook to calculate and manipulate the data, in which I import it and I clean it up, and then I use this formula here to calculate the absorbance of all the different concentrations of red dye. This V0 is the voltage of the black cuvettes when zero light is being transmitted. This V solvent is the voltage of the pure water, and these give you the two bounds for which this system can operate. The V sample is then each of the different red concentrations, the voltage for each of those, to then calculate the absorbance for each of those samples. So in this example here, I simply plot concentration versus absorbance. And as you can see, the absorbance shoots straight up and then levels off here at the 2.5. So this is the upper bound for which this concentration can then be read with the absorbance. So much like Beer's law, this is the reason why Beer's law is only applicable to concentrations at a low value. Beer's law assumes that absorbance and concentration form a linear fit, which, as you can see at a small concentration here, as we remove some of the upper concentrations, it appears to be more and more linear. And this is what Beer's law assumes. In this example, I use a sigmoidal curve model to then fit the data. The reason I do that is I change my concentration and I take the log base 10 of that and determine a model based on the log concentration and the absorbance. This helps to spread out the data, and as you can see, it appears to have this S-shaped curve to it. This is why I use the sigmoidal, as to get the best fit for the log concentration versus absorbance. As we move down, the blue dots here are data that I calculated previously prior to the videos just to get a fit for my spectrometer. The red or the orange line is my model using that sigmoidal model up above. The red dots are the concentrations of the red dye from the video using my spectrometer, while the black dots are the absorbance of the concentrations using the industrial spectrometer. As you can see here, the industrial spectrometer appears to increase in absorbance a lot faster than my spectrometer. This is more than likely due to the range in which the industrial spectrometer is able to pick up. My belief is using this equation up above with the log base 10 is their V solvent and V0 are actually closer together than the voltage that my spectrometer is reading, hence why there is a steeper curve to their data. This is why you always need to make sure that you have your upper and lower bounds to then be able to determine the absorbance of which the concentration is going to give off. You're always going to have an upper and lower bound, while some spectrometers are going to do better at a wider range versus others that are going to do better at a steeper or a shorter range of concentration. And this ends this video in which we talk about the spectrometer and my spectrometer versus the industrial spectrometer and its uses on finding concentration of an unknown substance.